Here's an example of finding areas in polar equations. So I've graphed a polar equation. R of theta is theta over 2 plus 1. The graph looked like this. I just plotted a bunch of points and figured out what was happening. And my question is, find the area enclosed in this little loop here. So the key to finding any area in polar is to find the angle that you start integrating at and finding the angle that you stop integrating at. So let alpha and beta be the start and end angles in my integral. So in the picture, here's what alpha and beta could be. So remember, in polar, you rotate a certain angle, alpha, and then you travel a certain distance, r, to get to the point you're interested in. In this graph, I'm interested in finding the two angles that give me the same point on the curve. So the first angle maybe is alpha. So let's say this angle here is alpha, because if I rotate that amount alpha and travel a distance r, I'll land on that point. But what could beta be? Beta cannot actually equal alpha. It needs to be a different number. Beta could be alpha rotated an extra pi radians. So beta either has to be in the same direction as alpha or the exact opposite direction. So let me draw the situation when you have the opposite direction. This angle here going all the way around, I'm going to say is beta. Why is that an acceptable option? Well, if this r value happens to be negative, I could rotate beta radians, be pointing in the direction opposite of where I want to go, but then if r is negative, I'd walk backwards and land on the same point that I'm interested in. So alpha and beta can either be in the same direction or, as I've drawn, they could be in opposite directions. So let's see what happens if alpha plus, actually in this picture I'm rotating clockwise, so I'll do alpha minus pi is equal to beta. So that's the picture I've drawn here. I have some angle alpha, and then I keep rotating in this direction another pi radians, and I get beta going in the opposite direction. However, if r is negative, again, I'd be landing on the same value here that I'm interested in. So let's see what happens if this relationship is true. What I need to happen is r of alpha to be the opposite of r of beta. Again, I have this negative sign because I need to be walking backwards when I look at beta. Okay, so I can plug in alpha and beta into this equation, and I get alpha over 2 plus 1 should equal negative beta over 2 plus 1. I don't like fractions, so let's multiply everything by 2. So I get alpha plus 2 should equal negative beta minus 2. So I guess alpha is negative beta minus 4. Now, alpha is related to beta using this observation. So I'm going to replace negative beta with alpha minus pi. Adding alpha to both sides, I get 2 alpha is positive pi minus 4, which tells me alpha. Alpha could be negative 2 plus pi over 2. So I found my alpha, and if this is my choice for alpha, then beta is alpha minus pi. So I take this alpha, I subtract pi. I think if you subtract pi, you'll get negative pi over 2 instead of a positive. Okay, so I found my alpha, I found my beta. I could find the angle that I start integrating, and I could find the angle that I stop integrating. So the area is now an easy integral calculation. The area is 1/2 the integral from beta to alpha. Now I chose beta to alpha because I'd like to integrate from the smaller number to the bigger number. 1/2 the function r of theta squared d theta. So this is the integral from -2 minus pi over 2 to -2 plus pi over 2. 1/2 the function theta over 2 plus 1 squared d theta. And now it's basically a routine integration problem. You can expand this out, FOIL it, or even maybe you could do a u substitution. Why don't we do that? Why don't we do a u substitution? Why don't we do u equals theta over 2 plus 1. Then I get du is 1/2 d theta. I have the 1/2 d theta here, so I get a new integral. When you change the limits of integration, if I'm at theta equals -2 minus pi over 2, that's my theta value. I think my u value should be -1 minus pi over 4 plus 1. So I go from -pi over 4, and then I think this up here would be positive pi over 4. The integral of u squared du. So the final answer would be 1/3 u cubed evaluated at -pi over 4 and pi over 4. So that would give me 1/3 pi over 4 cubed. Then I guess I have to do minus a negative, which would give me a positive, another factor of 1/3 pi over 4 cubed. So I guess the final answer, 2/3 pi over 4 cubed. All right, that was a tricky problem, not because the integration necessarily was tricky, but I think finding the alpha and the beta was a little bit tricky. That's why I was showing it to you as an example. All right.